Alright, what I want to do in this one, in this demonstration, is look at section 5.9. Now, it's a big section, there's some other things in there. The only thing I want to focus on at this moment is writing equations in standard form. So if you're given certain information, can you write the equation in the standard form? Remember, standard form is y equals ax with something plus bx with something plus cx with something plus ... plus a constant. Okay? So what we're going to do, very much like we did with our quadratics, is take something where we have points and find the equation for that point. Okay? Now, let's take a look at this. So for instance, 5.9, find the equations. We have a function that passes through these 4 points. -1, 0, 0, -12, 2, 0, and 3, 0. Okay? Now, how many roots are there? Well, there's 3. Because the root, remember, is when x is equal to something when y is equal to 0. It's the point where on the x and y it crosses the x-axis. That means that y has to be 0. We have 3 roots here. Well, what's 0, -12? That's the y-intercept. That's where this thing crosses the y-intercept because x is 0. So when we're given all the roots and a y-intercept, we can generate an equation for this in standard form. Won't graph this. Okay, you don't have to graph this. We don't even know what it would look like yet. Once we get the equation, we could. Let's generate that equation. We know it's going to look something like y is equal to a constant x minus p x minus q x minus r. Okay, we know it looks something like this because notice these are our 3 roots. 1, 2, 3. If we multiply these together, we'll get an x cubed term. Okay, x cubed term. Now, it could be higher. Could be a higher power because these could be double roots. So for instance, if it goes here twice and it's a turning point, this is an x to the 4th graph. But we'll give the least possible, could be at least it is a cubed function. It can't be lower than that because it has 3 roots. It could be higher though, because these could be double or triple or quadruple roots. Okay? But this will give us the lowest power it can be. Now, we need to plug in here. Let's do that. Y is equal to a, that's the constant, we'll do that for a minute. Now, first root. It's -1, 0, so it's x plus 1. Remember, if it's inside the parentheses, it has to be the opposite. Okay? So this is x equals -1, so x plus 1 is equal to 0. Second one, this is x minus 2. Okay? X minus 2. It's a positive 2. Now the last one, this is x minus 3. Okay? So we have our 3 roots. -1 because it's a positive 1 here. Positive 2 because it's a negative here. And then positive 3 because it's a -3. Now we still have too many unknowns. Okay, we've got this a. We've got to solve for the a. How do we do that? Well, we've used 1, 2, 3 of our points. Now we need to use our last point. Let's plug in for x and y. Alright? So y is equal to -12 equals a. Now in the first one we have 0 plus 1. Let's put a 0 wherever we find an x. 0 minus 2 for the second one, and 0 minus 3 for the third one. Okay? Now let's just simplify this. -12 equals a times 0 plus 1 is 1, 0 minus 2 is -2, and 0 minus 3 is -3. Okay? Let's simplify again. -12 is equal to a times 1 times -2 is -2, -2 times -3 is positive 6. How do we solve for a? Well, a is just going to be dividing this -6 out of here. So divide both sides by 6, and a, just rearranging, is -2. That's a. Alright? Now, the final point is, let's rewrite this as our equation in intercept form. Y is equal to -2, x plus 1, x minus 2, x minus 3. Okay? So in intercept form, this is what the equation looks like. In intercept form, -2, y equals -2, x plus 1, x minus 2, x minus 3. Okay. Now, I know you want to go further with this thing, so we need to put this not in intercept form, but into standard form. Let's do that. It's not that difficult. Let's pull this, I'll pull the sheet off and we'll do that. And that'll give us an equation in standard form, and we have an x cubed.